All right, in this video, we're going to talk about the existing paradigm, the linear paradigm, the recipe paradigm of the genetic code. It's important that we understand what it actually says, what it actually does, how it came about. It's a very interesting story. It's very important. Um, it's not like these people who did this didn't do anything worthwhile. And they made tremendous advancements, but we can't use that to excuse their mistakes, and their mistakes are legion. So I think we need to get a handle on exactly what it is. I like to go back to the early 1940s. Erwin Schrodinger wrote this book, What is Life? Erwin was a obviously brilliant nuclear physicist or a mathematician, and he contributed to the formation of quantum mechanics, the Schrodinger equation, Schrodinger's cat. All of that is relevant to life. Schrodinger had excellent instincts, and so he decided that he would ask the question, what are the laws of physics and chemistry that explain not just life, but he was more interested in his own brain, his thoughts. How does the universe create my brain, basically? And he was on the right track. Well, this is like 1940, 41, somewhere in there. Anyway, 1953 comes along. Watson and Crick stumble into the double helix. They become famous. Everybody's happy. Obviously, it's a code. They describe it as a four-letter collinear binary pairing code. And so they equate that with a computer. It's molecular information, incarnate. Okay, so far so good. I don't have a problem with that, but their interpretations start to jump the shark pretty quickly. A lot of this stuff, a lot of this information, you don't have to look at anything new to understand it. You can go back to the old stuff. I think this is Crick's book about life. He properly entitles it Life Itself, Its Origin and Nature. His description of the origin of life, we'll get into this a little bit later. You can see it on this picture. This circle is where the spaceship orbited the Earth and then landed on the Earth and brought life to the Earth. So right out of the gate, just knowing that, this is like 1980 something. Francis Crick. This guy, obviously, he did a lot of great things, but I specifically single him out for most of the mistakes that were made. Doesn't make him a bad person, but anyway, no, hard no. Not gonna do that one. Here's another guy. This guy's Scottish. A.G. Cairns Smith. I don't really know a lot about him, even though I have a background in geology. I should know more. He came up with this idea about the origin of life that is excellent. I don't agree with everything, but I don't agree with everything on anything. That's an older book, 1985, I think. It's worth looking at. This is not the actual book. I can't find it. I ordered another copy. It's supposed to be Claude Shannon's Introduction to Information Theory. Anyway, you gotta know information theory if you're going to talk about a code. I mean, that's goes without saying, but they didn't. So unfortunately, that was a mistake. This is the book that's relative to our discussion. This was written in 1961, Thomas Kuhn. He talks about the structure of scientific revolutions. This is where you get the concept of a paradigm and a paradigm shift. It's essential to know this stuff if you want to try and understand the nature of this paradigm that we've got now and why it can and must and will shift. It's going to shift pretty soon. I can guarantee you. It can't go on forever. Nothing this bad can keep going. Now, there's a newer book called What is Real. It's by a younger guy named Adam Becker, and he talks about this exact same stuff. And I like it better because Kuhn's a little bit dense. It's hard to follow, but Becker's easy to follow. He makes it real. He talks about the paradigm called the Copenhagen interpretation about quantum mechanics and how he basically shows that most scientists are positivists and what we ought to be is realists. So instead of taking this attitude that, all we need is calculation. No, we need to know how it actually works and why it works. So the recipe mode is pure positivism. It's just positivism all the way down. I think Becker's going to be really interested in this genetic code paradigm, because this is a real world chance to watch a paradigm shift in real time. I don't think it's going to take all that long. It's not going to take, it's not like Copernicus. It's not going to take 1,600 years. I figured it'll probably take another couple of years once people start to understand how bad this is. So far, it's taken me 3 decades. I can't get shit to work, but that's why I'm doing these videos. So anyway, we now know the setup. 1953, this comes out. This guy named George Gamow, who was this wacky-ass Russian theoretical physicist, very brilliant. He comes to the United States. He contacts Watson and Crick. He says, hey, dude, we got to get this thing going. We got to make this code between this DNA and protein. We know there's a code there. Let's bust this thing up. So he created this thing he called the RNA Tie Club. This guy was really eccentric. And he comes out of the gate and he starts making these theories about this code. So they did this math. They said, okay, there's 4 nucleotides and they're going to be paired in 3s, and so we'll call that a codon. And then we'll pair these up with these 20 amino acids. And so he made this concept of a diamond code where he was going to take this double helix and try and mechanically fit these things in. I can't remember whether this was first. The one that's relevant here is I can't believe I can't find an image on Google for Gamow's compact triangle code. And what he said was, if we look at these 4 nucleotides and we put them in 3s, then that'll create 20 distinct sets of 3. And so we can make, for instance, if we call that so here's just 4 of the 20. So if blue is A and red is T or U, whatever, then one codon would be A, and then another codon would be A, T or U, or it could be AUA, or it could be UAA, and likewise AUU. So you could do this 20 times. Well, there's 20 amino acids, there's 20 codons. It seems like it's very logical, it makes sense. But as they actually started to get the experimental data, this proved that it was false pretty quickly. I can't remember how many, 2 or 3 codons. Anyway, so Gamow was thinking in terms of logic and math and geometry, and he was right. This is a real codon table. This is not. This doesn't have any codons. This defines codons in a logical and mathematical way. Anyway, so that's where it got started. They started doing these experiments. They started getting this data, and the data was just fantastic. I mean, it was science fiction more than science. And so they assembled this table, and they could. This is just a data table, and it's a graph. It's a mathematical graph. So you can mathematically link up all of the elements. We have 2 sets. We have a set of molecules that are nucleotides, and we have a set of molecules that are amino acids, and there's 20 of these, and there's 4 of these. We do simple math, and there's 64 of these. Well, this table is a graph of this math, and so we go A, and that's lysine. And it's lysine every time. In other words, it's a one-to-one relationship. It's linear. Okay, it's determined. It's not, there's no probability involved here. It's a simple, linear, determined code. And this table perfectly encapsulates that code and everything you need to know about it. So this codon table, the table of all possible codons, became known as the genetic code really quickly. And you could say certain things about it. You could look at it and you could say it's simple, it's linear, it's deterministic. You could look at these patterns of these assignments and you could say, well, they're arbitrary, so it's arbitrary. You could say that, well, it's degenerate. In other words, there's more codons than there are amino acids. So it's degenerate. There's more information in the nucleotides than there is in the amino acids. This is what they said. This is not what I'm saying. Okay, you can say it's one-dimensional. The only information is the assignment of the codon to the amino acid. That's another way of saying it's linear. Then they went on and they said, well, look, okay, we get this sequence of nucleotides and it creates a sequence of amino acids. And the sequence of amino acids is not the goal. The goal is a protein. Well, how do we get the protein? And they said it doesn't matter, because once you have that sequence, you're done. The protein can only fold one way. So it's one-dimensional. There's one gene, and it goes to one protein, and the protein can only fold one way. And the only information that's passed, the molecular information, is one-dimensional. So molecular information is one-dimensional. So they get this point across by using the aphorism that sequence determines structure. So once you know the sequence, you know the structure. This kind of math that they're doing clearly is Euclidean math. We'll go into that a little bit later. But this is not describing any force of nature. It's not even describing a code, really, because there aren't any variables. There's no math. There's no logic. I mean, the logic is the premise. We take the premise, the conclusion. So this would require, if you try and extrapolate back in time, these molecules are the code. So, and they're doing these incredible things. They're very complex, and without these molecules, it doesn't work. So, in order for it to be functional, we must have these molecules. So there's an imperative that we have these molecules, which means that it can't change. It's frozen. It's arbitrary, which means it's accidental. It's frozen, so it can't change. So they described it as a frozen accident. Okay. And which means that, well, if it can't evolve, if it can't change, then the origin of it, as you extrapolate back, must be at a certain place in time where all these molecules came together. So that's why Crick proposed that, well, this is logically impossible, so let's just bring them here on a spaceship. Again, that's a hard no. Now, as they went through and did these experiments, they found that this table that they made was universal. In other words, every life form uses it. Okay, so the table is universal, and they said it's the code, it's the language of life. So the genetic code, the universal language of life, is this linear one-dimensional data table. All right, I think that's pretty fair. I think we need to go into a little bit more detail because the details are important. So we have this set of molecules that we call DNA. Okay. That gets transcribed stepwise fashion into mRNA, which is another set of molecules. That then gets translated into an adapter molecule, which they call tRNA. Okay. And then that goes to the chain of amino acids, which are polypeptides. It's a chain, which then that chain folds into a protein. And a protein is this complex globule, incomprehensible globule. So what the genetic code in this paradigm actually is the leap from DNA to protein. And they say that this is molecular information being translated by a molecular code. The information is one-dimensional, therefore the code is one-dimensional. Well, this is an obvious homunculus. I mean, you can't say that. I mean, first of all, why are we ignoring all the facts? I mean, none of it works. It's just, it's amazing that they actually said this, that people believed it. They were told. Where's my damn? Okay. This was just pure marketing. And they had this fabulous thing that worked. It worked for this experiment they were doing. No doubt about it. They made this table. They said this table predicts this experiment. That's true. I don't have a problem with that. I agree that, yeah, there's this really high correlation between 3 nucleotides in DNA and 1 amino acid. Okay. But they were told by people who knew something that that's not a code. That's actually technically a cipher, a substitution cipher. I call it a recipe. I mean, nobody knows what a cipher is. Everybody knows what a recipe is. Okay, well, they're the same thing. You know, you take this thing and you replace it with this thing. There's no variables, there's no code names, there's no logic, there's no math. It's just a cipher. It's a simple linear. But then they go off, you know, half-cocked, way out over their skis. And they start saying all this crap, this garbage, this false. And we'll go down the list, and we'll just show that this is stupid. But anyway, it's become a cult. I mean, this belief system that this description of this thing is accurate or even useful, it's not. They confused the fact that, you know, knowing this stuff is very useful. You know, you can take this data and develop all kinds of ideas and technology, and it works and all that, but it's not real. It's not true. This description is false. It's logically, empirically, every time they test this idea, it fails. I don't even know why we even need to discuss rejecting it. I mean, why do we want to keep saying something that's so false? But anyway, now that we understand what it is, in the next video, we'll just go down and, you know, we'll take it apart and we'll say, well, false, false, everything's false. And then that will allow us, I mean, we have to do this. If we don't, then we can't move forward. So that's what we'll do in the next video.